Alright, so let's just jump out of this thing. Just call this, I guess, SOP R&D or something. Let's make another one. Let's just copy this. This is maybe just copy the node that we have. And let's call it tops. Right, so a lot of stuff that we have, we can actually also just keep. So yeah, we have these names here. Let's just move this to the side. Let's make a dot network. Right, let's plug it in there. Let's maybe move it up a little bit. 0.2, let's maybe rotate a little bit or something. Right, something like that. Now let's make a rigid body solver. Let's say a RBD packed object. And let's do a ground plane. Let's merge in the ground plane here. All right, let's put this to first context geometry. Let's add gravity. Right, so that's pretty simple. Let's maybe hide our ground plane. All right, so where to start? Well, there's multiple ways we can sort of do the attraction towards the original position. Again, what we could do is we could just write it out ourselves with a we're doing this position thing. But what I just used, just to make it sort of a little bit just cleaner with just multiple nodes that each have their own thing, I just use a pop attract. But this pop attract essentially does what we do here with the just creating a vector in the direction of our original position. So let's go to goal. Let's put it to points, and let's put it to first context geometry. So what it will do is we'll and let's put it to point per particle, and let's do point and set it to point number. So what this will do, pop attract, is we'll attract them to a certain position. Like if I were to just set it to position like this, and I were to press play. Let me just go to this thing. So if I were to press play, and let's increase the force here, for example, you can see them being pulled. Just move it up a little bit. You can see they would be sort of pulled towards that point, like this. It's actually kind of already looks pretty cool. So let's undo all of those steps. Let's put it to point per particle again to point number. We don't have any IDs yet. We're probably gonna make some IDs later, but let's put it to point number. Right, so first, that's not really doing anything. Like, let's say if we were to put this to 100, you can see now it would sort of be pulled towards that location. We could, for example, keyframe this just to test it out. So on frame 0, put it to 0. And then let's put it to 10. Just try it out. Display, it's gonna fall. And then it's going to be pulled towards, we probably should increase that a little bit. Let's do it a little bit later. So let's shift these keyframes a little bit. But shift clicking on this channel, by the way, you can open up the channel editor. So it's going to flow to that point. And again, this is not very different. Like we could also do a geo-wrangle. And we could also just do it ourselves. So we could copy and paste like this entire wrangle. Let's remove this stuff. Let's remove the distance. And we could say that v at force equals P1 minus P2. And we could make a multiplier here. All right. So if we were to set this to 10. Oh, we need to go into data binding or into inputs. We need to put it to first input myself. So that's going to be its own data. And then second input is going to be the first context geometry. So that's going to be the this thing. So we're going to press play. Oh, we need to subtract them the other way around because now it's making a force that's pushing them away, which we don't want. So let's put it to, let's try 100. So you can see it's essentially sort of doing the same thing. But with this pop attract, you just have nice sliders already here. And also what it also has is a wrangle, because this is something we're going to be using as well. So you can type some wrangles to influence this force scale and stuff. So anyway, that's kind of why I did it using a pop attract. You could do this in a wrangle. We could build everything inside of one geo wrangle. I just split it up a little bit. So that's kind of why we're doing that. Right, so let's also test out our mixing of position. So I guess let's go to let's copy the wrangle in here. Let's make a geo wrangle. So again, with these geo wrangles, you can just do these same types of wrangles that you do in SOPs, but then in DOPs. Let's paste it in. Let's make a slider. Let's turn off our simulation brain, our model brain. Let's keyframe our mix a little bit. Yeah, let's play. Oh, and we need to go to inputs, myself, and first context geometry. Let's offset this thing a little bit to start a little bit later. Boom. And then it's gonna, there we go. So you can see it's gonna mix the position, and this should also work if we were to like put some random rotation in our transform here. So we could say $t times 12 in every single one. So in this case it would go, and you can see it would sort of go to its rotating position. So both of these things kind of work now, but we need to sort of put them together, right? So we have this pop attract thing here. We have this thing that we're doing here. So let's try implementing maybe so let's do this pop attract instead. So we want to attract it towards the center. Maybe we want to first define how are we going to attract these, because we want the center pieces to attract first, right? So the ones in the center. So we need to come up with a sort of a way to be able to do that. So there's multiple ways that we can do that. I'm going to do it a little bit different than I did in my original file. So if you download my original file, it's going to be a little bit different there. I used a volume sample there, but this probably makes more sense to do it with a distance, similar to what we did in the wrangle thing, because it's just probably a little bit more straightforward. Right, so we have these boxes here, and what I want to do is put a wrangle here. I want to say, I want to calculate a distance from the current piece to the zero to the center, kind of. So I want to say, for example, f at distance equals distance from the current position to 0. So you can see we get a distance value. So we could make a color. Let's make it exploded view. Let's say distance 0.7. We need to probably do the unpack thing again, because for some reason the color stuff is doing very strange. All right, let's do distance. All right, so you can see we get a black piece in the center and then white pieces on the outside. So And this would work on any geometry. Like I could put in a pig here. And let's turn off the shader. And well, you can see sort of there's one centerpiece there that's in the center. So it's going to be, probably if we put it like this, it's going to be making more sense. You can see this also works. So what I had initially in my original file was with a VDB from polygons. And then I used a attribute wrangle to do a sample. So let's do fill interior, unsigned distance field, and then do, so signed distance field is essentially surface is 0, it's negative on the inside, positive on the outside. I want an unsigned distance field and want more bands. So we can extract those values by type fat sample equals volume sample surface and by the position. You can see we also get some colors here, or some values there, and then we could also ramp from attribute, go from, but you can see these values are a lot smaller, so that's probably why distance might make more sense. 5 to 0.11. And let's do, I think there, oh, it's already unpacked here. Okay, let's do exploded. Let's do assemble, exploded view. Oh wait, I don't have it. I should put in the actual proper thing. Can remove the assemble here. All right. Okay, you can see now the values are a little bit different. So let's do unpack, because we need to unpack it again, because for some reason the thing is doing weird. And sample. Alright, probably need to invert it in this case. So you can see you get a sort of a similar thing. With a little ramp here that you can, but probably with the distance here, I think probably makes more sense. So let's go for the distance, just so you know that you can use both of these tricks. In order to make this a little bit more easier to work with, is to let's make these values between 0 and 1. So what we can do is go attribute promote. Go from point to detail, go distance, keep the original, take the maximum value. So if you use attribute, this is the easiest way to extract minimum maximums I found. So if you promote from point to detail, you can see it takes one value. You can say, for example, the maximum or the minimum. So we want to keep the original and we'll just want to call it max. We're going to do another one and we're going to do it minimum. We're going to call it min. So now we have both a minimum and a maximum value. And we're going to do another wrangle. We're going to copy this. We're going to say if a distance equals, we're going to fit something. We're going to fit the distance. We're going to fit it from min, so from min to max, and then 0 to 1. Oh yeah, at min and at max. Oh, by the way, I'm almost forgetting something. I should promote these probably back to being point attribute. So from detail to points. The max and the min back to point attributes. So you have min, max. All right, and now you can see, and we can, after this, we can delete these attributes because we only use them to min and max. Right, so what we're doing here is we're just taking the distance attribute, what was computed, then we're fitting it from the minimum distance to the maximum, so from the minimum distance to the maximum distance, so measuring between those two, and then we're going to fit it between 0 and 1. You can see then we're left with a distance from 0 to 1. And then if we were to put this inside of a thing, you can see we have a little bit more control this way. And probably we want to invert this, so the centerpiece is 1. So now this centerpiece here should be 1. I just double check it by blasting it away. You can see distance is 1. Right, so that means that if we have a 0 to 1 thing there, we put that into our dynamics. So let's remove this stuff. And it's so weird with these colors, man. I don't know why that suddenly happened. Because if you do this in other Houdini versions, the color should be fine. So I'm honestly, maybe I missed something with some release updates, but this didn't happen before. Anyway, let's go in here. Let's put back our actual box instead of our pig. Boom. Right, let's remove the color, by the way. We don't really need the color. Right, we can use this with attraction. So let's maybe say that we don't want to start the activation until frame 50 or something. So $frame above frame 50. So then first you have time to fall. And now let's say that we want, let's say make the force scale 100, which is probably a little bit much. But let's say that we want to do force scale times equals distance. Maybe we should call the distance thing something that's not known by Houdini by itself. Let's call it dist. It probably makes more sense. So let's remove the distance attribute. Right. So let's just use the dist attribute. Probably makes more sense. Else we're going to get confused whenever we compute more distance stuff. Right. So let's play. So it's a little bit extreme. And let's, by the way, maybe still add some primitive colors. So let's do primitive. Let's do red. Class primitives. I want to. Let's do dist. Keep the original. Go to prim. Dist. Right. Maybe we don't even. Oh, yeah, we need to do that. Right. So then we have something to look at in our viewport. Let's do. Right, something like that probably makes sense. Right, so let's then have a look in our viewport here. Right, so you can see the one in the center here, yeah, gets the most attraction. Oh, and this is, by the way, maybe we do actually want to use a volume sample, because, or unless this also kind of looks cool, but if we're measuring the distance, we're getting a circle, of course. Maybe I'm going to switch this from the distance to the volume sample. So let me just try it again with the volume sample. Why did it add this wrangle thing that I don't want? Right. Let's say the distance here is the volume sample. And we're just gonna plug that in here. Gonna remove that. This should all still work. Oh, what we probably need to do is we need to put this into the actual fracture geometry here. All right, and let's go down here. Oh, okay, now you can see now it works. So now we have a nice little sort of centerpiece here. So again, like this all just works the same, but again, it'll probably depend on what you're gonna do. So yeah, like I mentioned in my original, I also had the volume sample here. So we have a sample here, so it is from 0 to 1. All right, so I guess let's go back to our little dynamics thing here. All right, so probably what we want to do here in our pop attract, let's grab that attribute that we had, let's fit it. So we have some control in here over the minimum and the maximum stuff that we're gonna do. So let's say that float dist equals fit 0, 1 dist, and then we want to put it between certain values. So let's just call some float min. Let's say 1 or 1. Float max equals 1. Let's do min max. And right, there's a hidden button here. This is interesting. I've never accidentally like there's on the vector angle. There's you can press on this thing, expression, to do that. But apparently on the pop track it's hidden. It's like a little hidden button here, which they probably hope nobody would see, but it's there, guys. Look, boop. Anyway, all right. So what I'm doing here is I just creating a placeholder variable for min and max, so we can write a little wrangle for each of these things, because maybe we want to do that. So from 0.1 to 1, and let's first press play. And you can see this one is being attracted quite a lot. So maybe we want to do that a little bit different. Maybe we want the minimum. So maybe something else that we want to do is let's initialize an age attribute. So drops don't have age by themselves. Let's make a geo wrangle. We're going to use this geometry wrangle anyway later. But let's already use it to sort of initialize an age attribute. So let's type f at age plus equals at time increment capital T, capital I. That's important, else it won't work. So if we were to go on our thing on the right here, and let's have a look, we should have an age here. Right, so if I press here and I check the age, it probably looks like it's not working. It is, but it's because there's still a ground plane here and we don't want to load our ground plane. So we only want to load our already packed object. So you can see it's this because there was a ground plane there, which was also loading in. Of course, that isn't aging. So yeah, now we have this thing. Now we can use this age to influence our stuff in here. So we could, for example, say is distance times h, for example. Let's just try, see what that's gonna do. It needs to be at the distance. It's probably gonna change the minimum here to a little bit higher. Let's see what happens if I just put it to 1, because it should. Oh, and we need to, I'm grabbing the original distance there, which is of course not what we should do. We should do it like this, right? So let's just play. So now surely, yeah, you can see starting to pick up speed here. So we should probably increase this a little bit. All right, yeah, that's looking better already. So maybe let's say 0.2. Then I think we're probably good to go to proceed to the next step. Right, so yeah, that looks pretty good. By the way, let's change our frame rate to be something like 30. Still on 24, but let's just do 30 because Instagram, you know, whatever, interwebs. All right, so we have the basic stuff here going on. Now let's start playing around a little bit more in our wrangle here, in our geometry wrangle, and start implementing some of this stuff. So the sort of the mixing stuff that we did before.